All right, so we are continuing on to section 1.3 today. This is our second day of solving equations. We're going to move on to some multi-step equations and equations with variables on both sides. For that warm-up review from yesterday, go ahead and try those on your own. You can check your answers with what I have here. You can pause the video if you need to look at those more, but making sure we remember that we always undo the addition or subtraction first, and then we undo any multiplication or division second, so that we can get the variable by itself. We are always using those inverse operations. So addition and subtraction are inverse operations from each other, and multiplication and division are inverse operations of each other. Okay. All right, so jumping into 1.3 with solving equations, we're going to move on to multi-step equations. Our goal here is still to get the variable by itself, so we're solving for that variable. We need to look for like terms to combine. Sometimes we'll have the distributive property to take care of. But those are the main things we want to look for, is like terms and distributive property. So looking at number 1, I have 8n and I have negative 3n. 8n minus 3n gets me 5n. Bring down that minus 4 and equals 21. Now this looks like our two-step equations we were solving last class. Undo that subtraction with addition, inverse operation. Bring down the 5n, the negative 4 and positive 4 are canceling each other out. We're going to get 0 there. 21 plus 4, we get 25. Last step, we have 5 times n. Undo that multiplication with division, and we're left with n equals 5. So the only added step there was the combine like terms at the beginning. All right, for the next one here, number 2, we have 2x equals negative x minus 6. I always like to put in a 1, so I know it's negative 1x minus 6. For this, we have variables on both sides. We need to get all of the variables on one side, all of the constants on the other, then we can finish solving. So I know I have a variable here and I have a variable here. I need to move this negative 1x over to get it to the other side. It is a negative 1x. I'm going to add 1x. Add 1x. 2x plus 1x, I get 3x. Negative 1x and positive 1x are going to get me 0. They're going to cancel out. And I'm going to bring down that negative 6. Really watch that you're including that negative on the 6 when you bring it down. Now this is just one step left. 3 times x, we divide by 3 to get that x by itself. And x is equal to negative 2. Number 3 is very similar. We have our w variables on both sides. We need to get those all on one side. I'm going to go ahead and move the 6w away from the constant, negative 5. So I'm going to subtract the 6w on both sides. Positive 6w minus 6w will cancel out. When you bring the 5 down, make sure you bring a negative with it. Negative 5 equals 8 minus 6 is 2, so I have 2w. Negative 5 equals 2w. 2 times w, divide by 2 on both sides. Let's leave it as that fraction. That fraction will not simplify any farther, so I have negative 5 halves. All right, so we've seen some with combining like terms and then a couple with variables on both sides. We're going to continue on to these next 3, 4, 5, and 6, where we have variables and constants on both sides. So on number 4 here, again, I want to get all of my variables on one side and all the constants on the other side. I like having my x variables on the left. A lot of you like that as well. So I'm going to go ahead and choose to move this 9x over to the left side. You can move any term you want, as long as you're using those inverse operations to move it across the equal sign. But a lot of us like to have the x on the left side. So the 9 minus 9 is going to go to 0, so we're going to cancel that out. 4 minus 9x. Really watch your signs here. We're going to get negative 5x. Bring down the plus 8 equals, and then make sure we keep that negative on the 12 when we bring it down as well. I'm going to go ahead and subtract 8, because this looks like our two-step equations we did last class. And we get to negative 20. We undo this multiplication with division. Make sure that you're including that negative on the 5 when you divide. And really watching your signs, negative divided by negative, I get positive 4. Okay. All right, so moving all the variables to one side, all of the constants, or all those numbers, to the other side. Number 5 is going to be very similar. This time, I'm just going to move the variables to the right side to show you that that still works. You will still get the same answer. So this time, I'm going to move this -7 over to the right side by adding 7k. Adding 7k. Make sure you're adding it to the like term. -7k, +7k will cancel out. I'm going to bring down the 10 equals 16k plus 18, adding those k terms, those like terms together. All right, on the right side, I have a plus 18. I need to move that across to the other side because because I need all of the constants on the opposite side of the variable, and I already have the variable k on the right side. 10 minus 18, I get -8. Bring down what's left over on the right side, which is just the 16k, because the other 18s here canceled out. Last step, 16 times k. I'm going to divide to undo that multiplication. -8 over 16 is equal to k. We've talked about leaving our answer as a fraction instead of a decimal. The only thing with this one is this fraction will actually simplify. So we want to go ahead and simplify to -1/2 for our final answer. 8 goes into 16 twice, so that's 1/2, keeping that negative on there. All right, and then number 6, very similar here. I'm going to get all of the variables on one side and all of the constants on the other. This time I'll go ahead and choose to move a constant first. Like I said, it does not matter what you move first, as long as you end with the variables on one side and the constants on the other. So I have 4a equals -3a plus 2 because I moved that 6 to the right side. Now that I have all of my constants over here on the right, I need to move my variables to the left side. So 4a plus 3a is 7a. Cancel that out, equals 2. Last thing, 7 times a. We're going to undo that multiplication with division. This fraction will not simplify, so I'm going to leave it as 2/7. All right. So those are the main ones with variables and constants on both sides. Again, making sure you get all your variables on one side, all the constants on the other. All right, 7, 8, and 9 here. We have a lot of distributive property. So we're going to make sure we take care of that distributive property, and then we will continue to solve like normal. So on number 7, I have 5 times a plus 9 is equal to 39. I'm going to show you a couple ways to do this. This one would work out best to distribute that 5. 5 times a, we've done the distributive property, we know that's 5a. 5 times 9, we know that is 45. And we're bringing down the equals 39. 5a plus 45 equals 39. This is a two-step equation. We've solved these before. We need to undo this addition before anything else. So I'm going to go ahead and subtract 45 and subtract 45. Bring down the 5a. The positive and negative 45 will cancel out. We will get 0 on those. And 39 minus 45 is equal to -6. Don't freak out when it comes to fractions, okay? 5 times a, we know we got to divide by 5. This fraction will not simplify, so I'm just going to leave it as -6/5. All right. I'm going to show you a different way to do number 8. We could still do where we distribute the -3 to both terms inside the parentheses and solve it like we did number 7. If you like that way, use that way, okay? For this one, though, I messed up. Okay, for this one, though, this -3 in front of the parentheses will evenly go into this -39, okay? So I'm going to think of it like my problem here. If I just had -3x equals -39, I know that I could just divide by that -3 to get x by itself, okay? In this case, I can do that same step, but I'm just going to use this in place of x like I just had, So I'm gonna go ahead and divide by that -3. And that leaves me with just the 5 plus a left equals 13. Okay. Then I have 5 plus a, it's a positive 5. I need to subtract that on both sides. And I know a is equal to 8. If you don't like that way, you do not have to use that way. You can still go back and distribute your -3 and do it like we did number 7. That's totally fine. But now you see that you'll get the same answer if you did it this other way as well. Okay. All right, I'm gonna go ahead and show number 9 both ways. The first way is when I'll show distributing 4 times x, I would get 4x, 4 times -6, -24, and then equals 12. Undo the subtraction with addition on both sides, and I have 4x equals 36. I would divide, and I would get x equals 9. If we did it the other way, I would have 4x minus 6 equals 12. I would start with dividing by the 4, bringing down what's left over, which is the x minus 6 equals 3. 12 divided by 4. Then add that 6, and x equals 9. As you can see, either way we do it, we get x equals 9. All right, so make sure you know what way you prefer when you are solving that distributive property. Over here, just to talk about it, number 7, 5 did not go evenly into 39. So that wouldn't have been the best option to divide on both sides, because that would have gotten some decimals, some fractions that would not have worked out as nicely. All right, last one here for our notes. Number 10, find and fix the mistake. So if we just kind of walk through their steps and see if we can spot our mistake here. So I see some parentheses. I'm gonna go ahead and distribute. 2 times v, I get 2v, that looks correct. 2 times -5 gets me -10, that also looks correct. Whenever we see this negative in front, that's like distributing a -1. So I'm gonna go ahead and distribute -1 to both terms. -1 times 3v, -3v, that works out. -1 times 5 would be a -5. So that should not be +5, that should be a -5. If it is a -5, it's going to change our answer as we continue. So let's pick up at this step over here. 2v minus 10 equals -3v, but instead of +5, we're going to have -5. Now we'll go ahead and finish solving it. I'm going to move all of my variable terms to the left side. So that means I want to move this 3v over. So I'm going to add 3v, opposite operations, inverse operations to move it across. 2v plus 3v is 5v, minus 10 equals, those cancel, bring down that -5. All right, two-step equation. This looks like what we did last class. 5v minus 10v, I need to move that minus 10 over with a plus 10. Cancels out. 5v is equal to 5. Last step, 5 times v, I know I need to divide. So I have v is equal to 1. So v is not equal to 3, v is equal to 1. We changed the sign because the mistake was distributing there. All right, that is the end of 1.3.